Putting up crown in a vaulted room is so simple. Hi, I'm Ron Paulk, designer of the Paulk Workbench, the Total Station, and the Smart Wood Shop. I did a 6-part video series where I put up crown in a room with a flat ceiling. Make sure I'll put a link to that and make sure you look at it, because a lot of what I do will be referring back to that. I took a lot of time to show you how easy it is to put up crown. And almost everything that we need to do here, we did there. The thing is we've got angles to deal with, and a lot of people, a lot of contractors, a lot of finish carpenters, very skilled finish carpenters, don't know how to do this or make it much more complex than it needs to be. Every joint that we need to cut in here, with the exception of 2, will be the exact same joints that we would cut if this ceiling was flat. That's right. We're going to treat this as if it is a flat ceiling with very few exceptions. And it'll surprise you how easy it is. Now, first, the one thing that's different is we're going to have to get measurements for these angles, distance measurements, how long pieces are going to need to be. And so in a flat ceiling, I don't need mock-ups or test pieces, because I just measure to the points. I know what the cuts are going to be, as I showed you in that video series. But here, because of the angles, I need to make marks down from the ceiling where the crown touches, and plumb marks down from these angles. And so I need to make some test pieces so that I can come in here, hold them up, make some marks, and measure to those marks. So that's the first thing I'm going to do, is figure out what test pieces I need to make. I don't have any tools out. I just look around and I see a 90 there, inside 90, inside corner, outside corner, inside, outside. I've got an angled wall there that's not a 90, so I've got something that I've got to figure out there. I've got an inside 90 over there, an inside, and then just like this one, I've got another one down there. And then I have a joint, an angle at the peak on both sides. And this is a really complicated one, because I have this wall that's not a 90 degree that's cutting across that peak. So I'm going to have 2 different angles. I'm going to have one angle there and one angle there. This inside 90 and outside 90, I need to make a test piece to do both of those kind of cuts. I don't need to know the angle of the ceiling, and I don't need to know the corner. It's 90. I know I get a lot of carpenters say, oh, framing is so bad, and you know, it's really off. How do you do this? I treat them as 90s. I don't need to check, and it will be an absolutely perfect joint. And the reason I know this is that I've taught a lot of carpenters how to put up crown, and it's the spring angle that they get off. And I taught you how to deal with that in the 6-part series. Once you set that spring angle once on your saw, and you cut the trim up in position, and don't hassle with flipping the saw and doing a compound angle, because you can really get off with that. If you set the spring angle on your saw with the crown stop, the one you build in your shop, again, like I showed you in the other series, I've eliminated the compound question. All I care about is that corner. Because the inside corners, I cope every one of them. It doesn't matter if it's an 88 or a 92. It's going to be a tight joint. Outside joints, the same thing. As long as the spring angle is right, it's going to be really close. If it's way off, I may have to fool around with it a little bit, but you know, 99% of the time, I cut it exactly as if it's a 90-degree corner, and it works perfectly. So I don't need to get up and waste my time measuring any of these. I just know that I need to do an inside and an outside. So no measurements, nothing to worry about. Now I do have the 2 angles up there to do with the pitch of the ceiling coming together, and they're different. And this is rare. This is because this wall is bisecting the ridge or the center point of the vault. And so I know that that angle will be different. So it's adding an element of difficulty, but it's not really that hard. But I do have to measure that one, and I have to measure that one separately. So for this one, I could get out a long ladder, and I'm going to have one out anyway, and crawl up there with my protractor and figure out what it is. But what I'm going to try to figure out there is what the plumb is off of that angle, because that is going to be my cut on the saw. Well, I have the plumb right here. As long as this wall is plumb, this angle right here will actually save me one step, because it will give me one number that I can use with a little math on the miter saw, whereas if I get that one, I'm going to have to take that number and bisect it. And I will do that over there because that one's different and I don't have anything down low, so I will get a tall ladder out to do that one. So I've got my number here with my digital protractor, and it is 108.8. So that is the plumb cut that I'm going to do on the piece of material at that ridge on that end. And this is where it gets confusing for carpenters, even advanced craftsmen, when they start dealing with these angles. That angle is an obtuse angle, 108.8. But if you go to the miter saw, how do you cut 108.8? Well, I did another video where I explained that all miter saws are wrong. When you cut across the board, that's a 90-degree cut. But the saw says it's a 0. As long as you know that, it's really simple. So I take my 108.8 and I minus 90, and I come up with 18.8. So I'm going to cut an 18.8 on both sides of those. Now, there is no 18.8 on the saw, so I'm going to go to 19 and bump it a little bit short of 19. I'm not sure if you can see this, but the ridge comes through this way, and this wall is bisecting that angle, so it's changing the pitch here. And so I'm going to take my protractor and get it right into that ridge and check it. And I want to fit it in there good, because with the drywall mudding and stuff, sometimes it can throw it off a little bit. 154. So I take that number, 154, and I need to bisect it. I only need half of that angle. And so 154 divided by 2 is 77. Well, I have the same problem. I know that that plumb, there is no 77 on a miter saw, so I've got the same issue with 90. But in this case, I know that I need to take 77 and subtract it from 90. And I would have had to do the same thing if I did the ridge from there. Since I did it from the other side, it was the reverse formula. But in this case, with finding the pitch from both angles, I take the 77 from 90, and I know that that cut is 13. So I'm going to set my miter saw to 13. And again, there is a spring angle, but I've already set that in the saw once with my crown stop, so all I care about is the miter. So I know I'm going to cut a 13 and an 18.8, just less than 19 for there, to make those cuts. The rest of them, I'm going to go to the saw and cut them as if this is a flat ceiling. So let's go down to the shop and make those cuts. After lots and lots of editing, I found that this content
for showing you how to do crown on a vault was too long for one video. So this is going to be a 3-part series. And the next part, we go down to the saw, take the information we gathered from the room initially and make our sample pieces. And remember, these sample pieces are just to help us find our measurements, because we're measuring along an angled ceiling and it changes the position. If we were doing a flat ceiling, we just measure corner to corner, whether it's an outside corner, inside corner, it wouldn't really matter. But because of angles and the drop down, we need these little sample pieces. So we're gonna make them, and then we're gonna come back up and see how they fit. So to the saw next, but remember, the only measurement that I needed to make these pieces was the pitch of the ceiling, basically, because I needed that plumb cut. Everything else is just by eye. Outside corner 90, inside corner 90, outside corner 45, but we really know it's not a 45, it's a 135. So just remember that. Everything is identical to if the ceiling is flat, with the exception of our plumb cut for the ridge. That's it. If you like these videos, be sure to subscribe. When you subscribe, ring the bell. And also share the video with others. Toss in a thumbs up if you like the video. And if you want a set of my plans for the awesome rolling toolbox, the Paulk workbench, the total station, the stand-up desk, which I'm at right now, you can find all of that information in the description of the video down below. Thanks for taking the time to watch. Have a great day.